Hello, my name is Alexa Hurlbert, and in this video I will solve an example problem to explain how to use mesh analysis to analyze a circuit. The problem I will be solving is problem 31 from chapter 3 of the 4th edition of Fundamentals of Electric Circuits by Charles Alexander and Matthew Sudoku. When analyzing any circuit, the first thing you have to do is identify what you need. We are doing mesh analysis for this circuit, so for the first thing we need are mesh currents. Next, we notice that there are dependent sources in our problem. The dependent voltage source in this problem is dependent on I0, which we will find over here. We now need to put I0 into terms we understand. By looking back at our mesh currents, we see that I0 is equal to I4 minus I5. The dependent current source in this problem is dependent on V0, which we will find over here. V0 is the voltage across the 1 ohm resistor. Since I1 is the only current that flows through that resistor, Ohm's law tells us that V0 is equal to 1I1. The dependent current source causes another problem. A mesh current cannot contain a current source. Because of this, we will have to do what is called a supermesh, basically combining two mesh currents to surround the current source. As we go through and analyze these circuits, we will assume that the first current we analyze entering each resistor is entering the positive terminal. You can choose positive and negative terminals however you want. I've just always found this to be the easiest. When you enter the positive terminal of a resistor, the current is positive, and when you enter the negative terminal of a resistor, the current is negative. Tracing the parameter of the circuit, we find 1 ohm times I1 plus 4 ohms times the difference of I4 minus I5 plus 1 ohms times the difference of I4 minus I3 plus 4 I0 is equal to 0. Next, we substitute in for the value of I0 we found earlier and simplify. Our final equation is 1I1 plus 0I2 minus 1I3 plus 9I4 minus 8I5 is equal to 0. You might be wondering why I put the 0I2 in the equation, but trust me, if you do it now, it'll make your life easier later. Because we combined two mesh currents, we lost an equation. We can earn it back by analyzing a node in the supermesh. By doing this, we find that 2V0 plus I3 plus I4 is equal to 0. We substitute the value we found for V0 earlier and get the following equation. This mesh current is simple. I2 is equal to the 2 amp current source. Following the same process as was used for the supermesh, making sure to make the currents negative if they flow through the negative terminal of the resistor, we get the equation 0I1 minus 4I2 plus 5I3 minus 5I4 plus 4I5 is equal to 0 for this mesh. For our last mesh, we get 0I1 plus 0I2 plus 0I3 minus 4I4 plus 6I5 is equal to negative 10. Now for the reason we put all those zeros in the equations. If we lay them out nicely, they make a matrix. Now we can enter this matrix into a TI-84 calculator to solve for the currents. Once you have the matrix entered, you want to press the second button, then matrix, then hit the right arrow so that math is highlighted. Next, hit the alpha button, then the B letter button. You should see RREF open parenthesis on your screen. If you don't, you'll have to scroll through the list and press enter when you see RREF. Once you see RREF on your screen, once again, hit second matrix, then scroll as appropriate so that your desired matrix is highlighted, and press enter twice. The numbers all the way to the right are your mesh currents from top to bottom. They match the coefficients you entered from left to right. You can press the right arrow button to scroll to the right to see more sig figs if you need. Now that we have the mesh currents, we can calculate V1, 2, and 3. V1 is equal to 4 times I2 minus I3. V2 is equal to 1 times I3 minus I4. And V3 is equal to 4 times I4 minus I5. That's all there is to it. V1 is equal to 4.956 volts. V2 is equal to 4.846 volts. And V3 is equal to negative 0.112 volts. You can now use the same process to analyze other circuits.